Okay, what we have here is a numerical problem related to transportation problem. And what is transportation problem? A transportation problem is nothing but a linear programming problem that deals with finding an optimum solution. And in this case, finding an optimum solution to a transportation problem, wherein the shipping cost will be minimized. Now, a transportation problem can be solved using various techniques. The first one is Vogel's approximation method, VOGEL apostrophe S approximation. The number two is the least cost method. Number three is the northwest corner rule. Northwest corner rule. And of course, you have the modified distribution method, MODI in short, the modified distribution method. Now we are going to look at the first method of solving a transportation problem, and that is the Vogel's approximation method. Now before we solve, let us first read the problem. A company has factories at A, B, and C, which supply to warehouses at D, E, F, and G. Monthly capacities of the factories are A 30 units, B 45 units, C 55 units. Monthly demands at the warehouses are D 40 units, E 30 units, F 10 units, G is equal to 50 units. The shipping cost in rupees per unit from factories to warehouses is as given below in this matrix form. Okay, so you have the warehouses, you have the factories, and you are required to find an optimum shipping plan for the company. That means we have to find the initial basic feasible solution. All right, IBFS. So we have to find out what is the initial basic feasible solution. Now before you solve any transportation problem, you first have to see whether the problem is balanced or not. Now what do you mean by that, whether the problem is balanced or not? Now we have to find out whether the total capacity, 30 units plus 45 units plus 55 units, the total capacity is equal to the total demand or not. All right, so how do we do that? Okay, so we have the warehouses here, and this is the factories. A, B, C, D, E, F, G. So what we're doing is we're formulating the problem in this matrix. Now this is your capacities, your monthly capacities. So capacities. And this is your demand. So what is the demand for D? 40 units, E 30 units, F 10 units, and G 50 units. And what is your capacities? A, it is 30 units, B 45 units, C 55 units. Now I said we have to first find out whether the problem is balanced or not. All right, we first have to find out. So let's add 30 plus 45 plus 55 is equal to 130. Now 40 plus 30 plus 10 plus 50 is also equal to 130. So that means your total demand is equal to your total capacity. That means this problem is a balanced problem. So we are going to use Vogel's approximation method. In short, just call it VAM. Okay, and also we have to see what should be the number of allocations here. Is equal to M plus N minus 1. What is M? M is the number of columns, N is the number of rows. So column, there are 4 columns, 1, 2, 3, 4, 3 rows A, B and C. So plus 3 minus 1 equal to 6 allocations. Alright, so we're going to solve this problem using Vogel's approximation. There we have formulated the problems in a matrix. Now first step is we have to find out the penalties. Now what is a penalty? A penalty is the difference, okay, between the least cost, okay, between the least cost cell and the second least cost cell. So in this case, in column D, 5, 7 and 10, which is the least cost cell, 5, and the second least cost cell is 7. So take the difference of these two. Okay, that is the penalty. So 7 minus 5 equal to 2. Here in E, the least cost is 6, second least cost is 8. So difference of these two again is 2. Then in F, the least cost is 5, second least cost, now you have 2. Okay, 5 and 5. So take the difference of 5 and 5, that is 0. Then you have G. Least cost is 5, second least cost is 8. Okay, so 8 minus 5 is 3. So we found out the penalties for the columns. Let's find out penalties for the rows. Okay, in A, let's see which cell has the least cost. 5, 8, 5, 10. So we have 5 and 5, difference is 0. Then we have B. Least cost is 5, second least cost 6. So difference of that is 1. Now C. The least cost is 5, second least cost is 10. The difference of that is 5. So after finding out the penalties, the next step is to see which is the highest penalty from here. 2203510. So which is the highest? The highest is 5. So what you do is, okay, look at that cell that corresponds to C, okay, the column C, okay, which is the cell that has the least cost? It is CG, okay, cell CG. Now since we have the highest penalty 5 and the least cost cell is this one, we allocate whatever we allocate to this cell, whatever we can. Now what do you mean by whatever we can? It all depends on the capacity. Now here, what is the demand here? Demand is 50. Your capacity is 55. So therefore, can you meet the total demand, the full demand here? Yes. Why? Because your capacity 55, demand is 50. So allocate 50 here. Okay, cut this is 0 and we are left with 5 here. Okay, now cancel this column G, okay, because we have fulfilled the demand of G. Next, again I'll just write factories F. Okay, D, E, F, G, A, B, C. Demand 40, 30, 10. Remember, we have met the demand of G, so therefore demand here is 0. There's no more demand. Okay, and then your capacities 30, 45. Remember, we've allocated 50 here, so therefore you only left with 5. All right, so 5, 7, 10, 8, 6, 12, 5, 5, 20. Now we've met the demand of G, so we've cancelled G. Here we've already allocated 50. There we go. Now again, find out the penalties. Okay, find out the penalties. Okay, find out the penalties, and so take the difference. Take the difference. A 5 and 5, 0. B 5 and 6, 1. Difference in the under C 10 and 12, 2. Remember, what is the penalty? Penalty is the difference between the cell that has the least cost and the cell which has the second least cost. Now for D 5 and 7, so 2, 8 and 6, 2, 5 and 5, 0. Now do we have to find out the penalty of this? No. Why? Because we've already fulfilled the demand of G. We ignore G. Now from here, which is the highest penalty here? The highest penalty is what? Is 2. Now this 2, 2 and 2. Which one do we take? You take any one. It doesn't matter. Alright, you can take any one. Let's say we take this here. Take this 2. Now in column D, find out the cell with the least cost. Yes, it is 5. So allocate. Okay, from here, from A, you allocate 40. How much can you allocate here? Now you have 30, but the demand is 40. So how much will you allocate? Yes, you'll allocate 30. Why? Because we have only 30, but the demand is 40. So we've exhausted A. Alright, so since we only have 30 but the demand is 40, you allocate 30. You cannot allocate 40, right? Because you can only give what you have, and you have only 30 but you need 40, so you give only 30 here. So that you are still left with a demand of 10, but the capacity here is nil. So cancel A. Alright, next. Okay, what is the demand here? Demand is 10, 30, 10, 0. Capacity here is 0. Remember, we've exhausted A. 45 and 5. Again, find out the penalties. Remember, we have exhausted A, so ignore A. Alright, now find out the penalties. So what will be the penalty here? 7 and 10. Now we do not take this anymore, this cell. We have to ignore this cell. Why? Because we've already allocated. Okay, so you ignore this cell. You only take the difference of those cells where there is no allocation. So here, these two cells, the difference between 7 and 10 is 3. Difference of 6 and 12 is 6. 5 and 20, it's 15 nil. Here also we don't take the penalty. Now what is the difference? 1. 10 and 12, 2. So which is the highest penalty? Yeah, it's 15. Alright, now which is the cell with the least cost? Here, this one here. Okay, so what is the demand? Demand is 10. What you have is 45. Okay, so you allocate 10 here. Alright, there. Okay. Okay, we have met the demand of F, so it'll be 0. By the way, we cancel this. Okay, so here we're left with 5. This is 35. This is 0. Dash 6 and 12. Dash okay. Now again find the penalties. Find the penalties. So difference here, 7 and 10, 3, 6 and 12, 6. We don't find the penalty for these two because we have met the demand. Here also you need to find the penalty, 7 and 6, 1, 10 and 12, 2. Alright, now to find out which is the one with the highest penalty, 6. Find out the cost with the cell with the least cost. It is here. So allocate how much you have. You have 35 and you need 30. You have 35, demand is 30. So how much will you allocate? Yes, you allocate 30. So here you're left with 5. Okay, so you've met the demand. Now you've met the demand of E, F and G. Now you're left with only D. Alright. Oh wait, 10, 0, 0, 0. This is 0, this is 5, this is also 5. 7, 10. Dash 6 dash dash. Okay, so now we only left with D. We have to fulfill 10. Okay, the demand here is 10, but how much do we have? We have 5 here, B, and 5, C. So what do? Do we need to calculate the penalties again? No need. It's not required anymore. Why? Because see, the demand of D is going to be met from B and C. Now B has how much? B has 5. Okay, so you allocate 5 here. Okay, now we are left with 5. Now D, there's a demand of 5, but there's still a supply of 5 here, C. So where do we allocate? We allocate this cell. So how much will you allocate here? 5, obviously. So 5's here. So now we have exhausted, okay, capacities. We've also met all the demand. Now all the demand is 0, capacity is also 0. So we have solved, we have found out the initial basic feasible solution. Now let us find out the total costs. Now before you do that, I always, you show your final matrix, and I always believe in you know a neat work. So show the matrix here, your final matrix with all the allocations. So 30 here, now how many allocations do we have? 1, 2, 3, 4, 5 and 6. Remember, we said we're going to find out the number of allocations is 6. So we have found out 6 allocations is 6. So the total cost, okay, the total cost will be 30 into 5 plus 5 into 7 plus 5 into 10 plus 30 into 6 plus 10 times 5 plus 50 times 5 equals to how much? So this is 150, 35, 50, 180 plus 50 plus 200 and no 250, sorry, this will be 250. All right, so if you add up, if you add all this, it'll come to 715. So there's your solution. So this is your final allocation. So this is how you solve a problem using Vogel's approximation method.